Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important topic that is from the classical mechanics CSIR syllabus. Already yesterday, I told about the periodic motion question. Periodic motion and small oscillation question I discussed in the yesterday's class. Yesterday's class means in the previous slide, in the 39th slide. So now the today is the 40th video. In the 40th live class, we are discussing about the next syllabus of the CSR, that is a normal modes, periodic motion, small oscillations and normal modes are there. From the normal modes, how we have to solve the question today we have to see. Now in GATE 2013, this question was asked. It is very simple. How this question we have to understand, that is very, very important. Consider two small blocks. Two small blocks are there. Now you able to take, this is one block is there. Consider two small blocks. Each of mass m. You have to take it as each of m. This is one block, each of mass m, attached to two identical springs. This is the spring constant is equal to k. This one also spring constant is k, attached to two identical springs. One of the spring is attached to wall. One of the spring is attached to the wall. What is this? This is the wall. One of the spring is attached to the wall as shown in the figure. The spring constant of each spring is k. The masses of slides along the surface. The masses are slides along the surface, and this is the friction is negligible. You have to take the frequency of the one of the normal mode is how much they are asking. The frequency of the one of the normal mode is equal to omega is equal to, how we have to calculate, we are going to see the frequency of the one of the normal mode. Now you have to see the solution, how we have to solve to find out the normal mode. So frequency of the normal mode, we have to follow the three steps, at least three steps you need to follow, and then you able to get the frequency. The fourth step, you have to get the type of the normal mode, but three steps you have to follow. So what is our system? First you observe the system. You observe the system means I understand the system. Now there is a wall is there, clear? There is a wall. This is the wall. For this wall, one block is mass m, one block mass is m. So this is attached with the spring. That spring constant is equal to k. Now this one more mass also is attached to the spring. That is the block m, right? Constant is equal to k. So now this one is moving with the x1 position. It is moving. So therefore that velocity of this block is equal to x1 dot. Now this is also moving with x2, right? Displacement, this velocity is equal to x2 dot you have to consider. Now you're able to see here that position is x2 minus x1. The spring, this position is equal to x1 because it is the wall. This one you have to take it as a zero position. It is the rest fixed point you have to take. So this point is the fixed point. Now this is the first, this is the understanding about the system, right? We need to calculate the one of the normal frequency we have to calculate. How we have to do? First, the first step is for concerning this problem, you have to write the first step. What is the first step? Write the kinetic energy and potential energy corresponding to the system. First, you have to write the kinetic energy and potential energy corresponding to the system. How we have to write the kinetic energy? T is equal to the first particle 1 by 2 into m1 x1 dot square. The second particle 1 by 2 m x2 dot square is there. This is the kinetic energy of the system. So the kinetic energy of the system, the first particle kinetic energy plus second particle kinetic energy. Now you are able to see the potential energy 1 by 2k x1 dot square plus 1 by 2k x2 minus x1 dot whole square is there. Clear? So therefore, what we have to write here? So this is the kinetic energy and the potential energy of the system. We have to calculate by like this. You have to calculate. Now the second step is, what is the second step? The second step, you are going to calculate, find the matrix form, matrix form of T and V. We have to calculate the matrix form of the kinetic energy, the matrix form of the potential energy we have to calculate. How we have to calculate the matrix form of a kinetic energy and matrix form of a potential energy? Now you able to see the kinetic energy, you have to write it is x1 dot, x2 dot. Here you have to take x1 dot, x2 dot. The constant you have to take it is outside. X1 dot is equal to m, x1 x2 dot is equal to 0. So therefore it is m. Therefore the matrix 0, 0 m, you able to get it. This is the matrix representation of a whom? The matrix representation of the kinetic energy. That constant we are not considering here. The variable things only we are considering. Now you able to take the potential energy, you know, the potential energy V is equal to 1 by 2 m x1 square plus 1 by 2 m x2 minus x1 whole square. We have to write this one 1 by 2 m x1 square plus 1 by 2 m into x2 square plus x1 square minus x1 x2 minus x2 x1. We have to write it is, therefore V is equal to 1 by 2 m, here x1 square 2x1 square plus x2 square minus x1 x2 minus x2 x1. We are taking, this is the potential energy. How we have to write in the matrix form? So here x1 x2 variables are there, here x1 x2. So the constant is you have to take 1 by 2, you have to take here. Now you have to see x1 into x1, x1 dot x1 square. So x1 square is equal to how much you have to get it? This is 2k, not m. So 2k you have to take, sorry, you have to take it as a 2k x1 square, 2k x1 square. So 2k x 2k you have to take, right? So k 2k you have to get it. So this is the 2k. Next x2 x1, x2 x1 is equal to minus k is there, x1 x2, x1 x2 also you have to take it as a minus k, and then x2 square is equal to k is there. So therefore the potential energy matrix is equal to V is equal to 2k minus k minus is the potential energy matrix. Clear? Now we have to calculate. This is the second step. What is our first step? First step is to calculate the kinetic energy and potential energy. The second step is to write the expression in the form of a kinetic energy and potential energy in the form of the matrix form. So now the third step is write the secular equation. Write the secular equation. What is the secular equation? Write the secular equation for normal frequency. For normal frequency, write the secular equation for normal frequency. How we have to write the secular equation for the normal frequency? Once you have to see V minus omega square into T is equal to 0. The modulus of V minus omega square into T is equal to 0. Now we know the V and we know the T. So those values you have to substitute here. You able to calculate. So how we have to calculate the secular equation? The determinant of V minus omega square into T is equal to 0. V is equal to, now only we know what is our matrix. V is equal to, so 2k minus k, 2k minus k minus kk. This is the v minus omega square into t is equal to m 0 0 m modulus of, so 2k minus m omega square minus k, here minus k minus m omega square is equal to 0. Now find the determinant and simplify. How we have to calculate the determinant, you are able to see here. So you have to calculate 2k minus omega square into, so k minus m omega square minus into minus plus, so you have to take it as a minus k square is equal to 0. Now you have to simplify this expression, otherwise you have to take it as a 2k square, 2k minus 2k m omega square, so k omega square, so k omega square you have to take it as a k omega square minus you have to consider as a k minus m omega square, k omega square you have to take it as a you have to consider m omega to the power of 4 minus k square is equal to 0, right? So 2k square, you will get the k square minus 2k m omega square, right? So minus 2k m omega square minus k omega square minus m omega to the power of 4 is equal to 0. So 2k square, so 2k m omega square, k omega square. Next you have to take it as a k omega square. So this is m omega square is there, no? K m omega square, k m omega square, k m omega square, m square omega to the power of 4 is equal to 0, right? So to get this from this, you have to calculate the omega value. How to calculate? How we have to calculate the omega value? Now you go for the options. To solve this, it is more difficult. So that's why you go for the options. Once you have to see the options, so once you have to take the option, wherever the option you have to take, first option you have to take, second option you have to take, and third option you have to take. So this third option, what is the third option? You have to see square root of 3 plus root 5 is divided by 2. So the you able to take the omega is equal to square root of 3 plus root 5 is divided by 2 into square root of k by m. So this option you have to consider. So now you substitute here, you substitute here, you substitute here, the right hand side and left hand side, you able to get the 0. So therefore this option is correct. Like this you have to do. So otherwise you have to solve this, it is most difficult. So that's why from the answers you able to go and you able to get it clear. So if you really likes my teaching, I'm daily informing you. We started the CSR and GATE physics content right in the online mode. So DL you have to take this one also, that is also very useful to you, right? App, you go to the Play Store mobile phone, you place the Quantum Online Academy app and then you download it and go to the stores. You will see the courses like this and you negotiate with me. My number is 9908437460. This number is in working condition. Now individual papers also available. Almost this classical mathematical methods of physics, core plus advanced, everything is recorded and available in our app. Now the classical mechanics almost core syllabus is completed. Core syllabus is completed. Advanced syllabus is live plus recorded classes are available. Live plus recorded classes are available. If you want to take right now, so 2 years validity is there. So if you have to take this course is 2 years validity is there. After finishing the syllabus, I won't give the 2 years validity. I have to convert it into 1 year validity only. So this 2 year validity I am going to convert it into 1 year validity, right? So please utilize this chance. So please utilize the chance. 1 year I need to complete the syllabus. No one can teach you entire the portion. This is my own institute with intense interest. I am teaching to you. Please utilize this chance. If you really interest, if you really likes my teaching, you have to utilize this chance. Otherwise, share and like and subscribe. Like this videos, live sessions also I will conduct in the YouTube. You listen and enjoy. Thank you so much.